All right, in example 2, we're just going to do the same thing we did in example 1, only we're going to do it for cosine of x. All right, so we're going to use the graph of cosine of x to sketch a graph of the derivative. Okay, we're going to find the derivative just graphically. All right, so I encourage you to feel free to pause the video, try this on your own, fast forward to the end to check. But I'll go through it here in case you want to watch me go through it. All right, the first step I'm going to do is just like I did before. I'm going to find where those points, those turning points, where the slope is changing direction, right? So I'm going to mark them on the graph here. These are the points where dy dx is equal to 0, right? At these points, dy dx is equal to 0 at these points. So I'm going to start by graphing, just plotting those points, right? I have a 0 here. It looks like at pi, and I'll have a 0 at 2 pi, and then in the negative direction, I've got one at negative pi and negative 2 pi, right? I've got all these points where the slope of the graph is changing direction, so it's passing through 0. All right? And then it's just a matter of looking at the graph, looking at the slope. You can see this first section between negative 2 pi and pi. It looks like the derivative, oops, dy dx is less than 0, right? It's negative, so I'm gonna sketch that over here on the derivative graph, okay? And I'm just gonna do that for all of these sections. All right, so I've done that, right? I've just looked at the slopes for these various sections of curves. It goes from negative, right? The slope is negative between negative 2 pi and negative pi. So the values of my derivative are negative over here. So, and then the slope is positive. And so I've drawn positive values of the derivative, and then negative, and then positive. All right, now you might wonder, how did I know to go up to 1? And I don't. Based on the graph, you know, it's hard to tell. Like, is that a slope of 1? I don't know. It's hard to tell. Like I said, this is not a rigorous proof of why the derivative of, of what the derivative of cosine is. This is just to give you a conceptual idea of why it is. So, so I don't know that it goes up to 1, right? But I drew it up to 1. And I know the end result is really the main thing, which you can sort of see from this graph. Graphically, it looks like the, let me write down here, dx of cosine of x is equal to, now this is it's another trig function, right? It's a periodic function. It looks a lot like a sine function, except notice that it goes down first, right? If I start from 0, 0, it goes down first and then up. So it's basically a sine function, but it's reflected across the x-axis, and so it's a negative sine of x. Okay, now that is the derivative of cosine of x, right? This is the end result, is that the derivative of cosine is a negative sine. So I've summarized that in this box here. These are the basic trig derivatives for sine and cosine, and from there we just get to use it. We can use it, and we can combine it now with things like sums and differences and products and quotients involving these trig functions. So that's what we're going to do next in example 3, is just practice using these derivatives. So I'll see you in the next video.